Imagine, for a moment, staring into the night sky. It seems peaceful, calm even, offering a sense of wonder and beauty. But behind this serene curtain of darkness and twinkling stars lies something far more terrifying. The universe, vast and unknowable, harbors phenomena so strange, so incomprehensibly powerful, that they could make the most hardened souls shudder with fear. These cosmic horrors exist beyond the edge of human comprehension, operating under laws and forces so alien that they challenge everything we think we know. This video will take you on a journey through the most terrifying, awe-inspiring aspects of the cosmos. We'll explore black holes that stretch reality to its breaking point, cosmic events that could wipe out entire civilizations without a trace, and the eerie possibility that we may not be alone in the universe, but that whatever is out there may not be friendly. But before we continue, subscribe to the channel so you don't miss out on any of these videos. To understand cosmic horrors, you must first accept that space operates on scales and under conditions that are completely foreign to our everyday experience. The vast emptiness of space itself, a nearly perfect vacuum, is hostile to life in a way that's hard to fathom. In space, there is no air to breathe, no warmth, no water, and no way to survive the relentless bombardment of radiation from distant stars. Yet, it's not merely the inhospitable nature of space that strikes fear into the heart, it's the events and objects that occur on a level that defies our most basic instincts about reality. Consider black holes, perhaps the most infamous of cosmic nightmares. These entities form when a massive star exhausts its nuclear fuel and collapses under its own gravity. The result is a point of infinite density, known as a singularity, surrounded by an event horizon, a boundary beyond which nothing, not even light, can escape. The idea that an object can warp space and time to such an extent that it creates an inescapable prison is disturbing enough, but the reality is even worse. If you were to fall into a black hole, you wouldn't just be crushed instantly. As you approach the event horizon, you would experience spaghettification, a process where the immense gravitational gradient stretches your body until it is torn apart atom by atom. Time itself behaves differently near a black hole. To an outside observer, you would appear to freeze in place as you neared the event horizon, never fully crossing into oblivion, while from your perspective, time would flow normally, with the universe around you accelerating into the distant future in a matter of seconds. But black holes don't merely exist in isolation, sucking up any unfortunate matter that strays too close. They actively influence their surroundings, warping space-time, swallowing stars, and merging with other black holes in cataclysmic events that release energy on scales that defy imagination. The merging of two black holes sends ripples through the very fabric of space-time, known as gravitational waves. These waves, traveling across the cosmos, stretch and compress everything they pass through, including you. Though undetectable by our senses, gravitational waves can distort reality itself. Even more terrifying is the possibility of supermassive black holes. At the centers of most galaxies, including our own Milky Way, lies a black hole millions or even billions of times the mass of our Sun. These monsters are not passive entities but dynamic forces that govern the fate of entire galaxies. They can flare up, consuming stars, gas, and dust in violent outbursts that send shockwaves across light years. If you thought black holes were distant threats, consider this: our own galaxy's central black hole, Sagittarius A*, could one day awaken from its slumber, disrupting the delicate balance of the Milky Way. But black holes are just one part of the cosmic horror story. Other phenomena, equally terrifying, lurk in the dark corners of space. Take neutron stars, for example. These objects are the remnants of massive stars that have exploded in supernovae, leaving behind a core so dense that a sugar cube-sized amount of neutron star material would weigh about 1 billion tons. Neutron stars have incredibly powerful magnetic fields, so strong that they can warp atoms into pencil-thin shapes. The surface of a neutron star is so hot that it glows with X-rays, and it spins rapidly, sometimes hundreds of times per second. The extreme conditions on and around neutron stars are unimaginable, and when two neutron stars collide, the result is one of the most violent events in the universe, a kilonova, which can outshine entire galaxies. The universe is also home to more elusive threats, such as rogue planets. These are planets that have been flung out of their solar systems by gravitational interactions and now wander the galaxy alone, without the warmth of a nearby star. Rogue planets could collide with other planets, moons, or even stars, causing massive destruction. And because they are not bound to any star, rogue planets are nearly impossible to detect. They could be lurking anywhere, even in the far reaches of our own solar system. Then there are gamma-ray bursts, the most energetic explosions in the universe. These bursts occur when massive stars collapse or when neutron stars merge, releasing a torrent of gamma radiation that can travel across billions of light years. A gamma-ray burst pointed directly at Earth could sterilize the planet, wiping out all life in an instant. The terrifying part? We wouldn't even see it coming. The burst would hit us before we had any chance to react, obliterating the atmosphere and cooking the surface of the planet. And what about dark matter and dark energy? These mysterious forces make up the majority of the universe, yet we have no idea what they are. Dark matter exerts gravitational influence, helping to hold galaxies together, but it doesn't interact with light, making it invisible to us. Dark energy, on the other hand, is driving the accelerated expansion of the universe, pushing galaxies farther and farther apart. Eventually, this expansion could rip the universe apart in a big rip, tearing apart galaxies, stars, planets, and even atoms themselves. The scale of these cosmic horrors is almost beyond comprehension. Our minds struggle to grasp the distances involved, the energy outputs, and the sheer power of these phenomena. But perhaps the most unsettling possibility is that we are not alone in the universe. The idea of extraterrestrial life has fascinated and terrified humans for centuries. But what if intelligent life does exist somewhere out there? And what if it's not friendly? Given the vastness of the universe, it's entirely possible that civilizations far older and more advanced than ours have already arisen. What would their goals be? Would they view humanity as equals, as curiosities, or as pests to be exterminated? There is also the Fermi paradox to consider, the contradiction between the high probability of extraterrestrial life and the apparent lack of evidence for it. Some explanations for the Fermi paradox are benign. Perhaps intelligent civilizations are rare, or perhaps they are avoiding us. But other explanations are far more chilling. Perhaps there is something out there, a cosmic predator, that wipes out civilizations once they reach a certain level of technological advancement. Perhaps the reason we haven't encountered extraterrestrial life is that they have all been destroyed before they had the chance to make contact. And if we do make contact, who's to say that it would be a peaceful encounter? Advanced extraterrestrial civilizations could possess technology so far beyond our understanding that they might seem monstrous. They could manipulate space-time, harness the energy of entire stars, or even transcend physical form altogether. The sheer scale of the unknown in this realm makes the possibility of contact with extraterrestrial life both exciting and horrifying. The universe is not a friendly place. It is vast, cold, and filled with forces that could wipe out humanity in an instant. We are a tiny speck of life clinging to a fragile planet, orbiting a nondescript star, in an unremarkable galaxy, in a universe that does not care about our survival. The more we learn about the cosmos, the more we realize how little control we have over our fate. The terrifying cosmic horrors that lurk beyond our understanding are a reminder of just how small we are, and how dangerous the universe can be. Yet despite our apparent insignificance, our curiosity about the universe and its potential dangers remains insatiable. We continue to push the boundaries of our knowledge, probing the depths of space in the hopes of understanding the mysteries that lie beyond. But with each new discovery, we are confronted with even more questions that force us to reckon with the terrifying scale and unpredictability of the cosmos. Consider the concept of vacuum decay, a theoretical end-of-the-universe scenario that is as haunting as it is plausible. In quantum field theory, the universe exists in what is called a false vacuum, a state that is stable but not perfectly so. This false vacuum could, at any moment, collapse into a true vacuum, triggering a chain reaction that spreads at the speed of light and destroys everything in its path. The terrifying aspect of vacuum decay is that it could happen at any time, anywhere in the universe, and we would have no warning. The wave of destruction would move so fast that by the time it reached Earth, it would already be too late. All matter would be obliterated, and the fundamental laws of physics would change, rendering the universe uninhabitable. While vacuum decay is a theoretical possibility, it highlights an essential truth about the universe. It is governed by forces we don't fully understand, forces that could reshape reality in an instant. The idea that the very fabric of the universe could unravel, without any input or control from us, adds another layer to the cosmic horror that surrounds us. And then there are the anomalies, phenomena that we have observed but cannot yet explain. One of the most puzzling is the existence of the so-called Great Attractor, a gravitational anomaly located about 150 million light-years away in the direction of the Centaurus constellation. The Great Attractor is pulling our galaxy, along with thousands of others, toward it at an incredible speed, yet we have no idea what it is. Its gravitational pull is so powerful that it bends light from distant galaxies, warping our view of the universe. But because it lies behind the zone of avoidance, a region of the sky obscured by the Milky Way's dust and gas, we can't observe it directly. The nature of the Great Attractor remains a mystery, and it raises the unsettling possibility that there are forces in the universe far beyond our understanding. Even more baffling is the dark flow phenomenon, which suggests that large groups of galaxies are moving in the same direction at an extraordinary speed, as if being pulled by something beyond the observable universe. This movement defies the current understanding of cosmic expansion, where galaxies should be drifting apart due to dark energy. The cause of dark flow is unknown, and some scientists speculate that it may be the result of gravitational influences from beyond the observable universe. This hints at the possibility that our universe is not alone, that it may be part of a larger multiverse, where other universes exert their influence on ours in ways we can't yet comprehend. Speaking of the multiverse, this concept itself is rife with terrifying implications. The idea that our universe is just one of many, perhaps an infinite number, in a vast multiverse challenges our understanding of reality. In some versions of multiverse theory, every possible outcome of every event creates a new universe. This means that there could be universes where the laws of physics are different, where time flows backward, or where life as we know it is impossible. There could even be universes where the very concept of existence is different from anything we can imagine. The thought that there are countless alternate realities, many of which could be hostile or incomprehensible to us, is both fascinating and terrifying. But perhaps the most unsettling aspect of the multiverse theory is the possibility that we live in a simulation. This idea, popularized by philosophers and physicists alike, suggests that our universe might be an artificial construct, created by an advanced civilization or even a higher dimensional being. If this were true, then the rules of our universe, everything from the laws of physics to the passage of time, could be nothing more than programming code, subject to change at any moment. The realization that we might be living in a simulation adds another layer of existential dread to the cosmic horror, as it suggests that our reality is not as solid or as permanent as we believe. This leads to another terrifying possibility, the concept of the Boltzmann brain. Named after the physicist Ludwig Boltzmann, this idea stems from the strange properties of thermodynamics and quantum mechanics. It suggests that, given enough time, random fluctuations in the universe could spontaneously create a fully conscious brain, complete with memories and a sense of identity. This Boltzmann brain would have no way of knowing that it wasn't the product of a long evolutionary process, and it could be floating alone in the vacuum of space, disconnected from any reality we would recognize. The frightening implication of this theory is that any of us could be a Boltzmann brain, a fleeting, momentary consciousness that will dissolve as quickly as it came into existence, with no way of knowing the truth. The universe's capacity for destruction is not limited to distant phenomena or abstract concepts. There are dangers much closer to home that could bring about the end of civilization as we know it. One such threat comes from asteroids and comets. These space rocks hurtle through the solar system at incredible speeds, and while most of them pass harmlessly by, it only takes one to cause a catastrophe. In fact, Earth has already experienced such an event, the impact that wiped out the dinosaurs 66 million years ago. A similar impact today would be devastating, causing massive fires, tsunamis, and climate changes that could lead to the collapse of human society. What makes this threat so terrifying is that we have limited ability to detect and deflect these objects. While space agencies around the world are working on methods to prevent asteroid impacts, we are far from having a foolproof system in place. A large enough asteroid could strike with little warning, leaving us with no time to prepare. The existential dread that accompanies the knowledge that our species could be wiped out by a random cosmic event is a reminder of our fragility in the face of the universe's chaotic forces. Even the Sun, the source of life on Earth, poses a potential threat. As a star, the Sun is stable for now, but it will not remain so forever. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, engulfing the inner planets, possibly including Earth. But long before that happens, the Sun could experience a coronal mass ejection, CME, a massive burst of solar wind and magnetic fields that can cause widespread damage to Earth's electrical systems. A powerful enough CME could knock out power grids, disable satellites, and cause chaos on a global scale. While it wouldn't be an extinction-level event, the societal collapse that could follow such an event would be catastrophic. All these threats, from black holes to rogue planets to asteroids, remind us of a sobering truth: the universe is indifferent to our existence. We live on a small, fragile planet in a vast, hostile cosmos, and there is nothing to protect us from the forces that shape the universe. But perhaps the greatest cosmic horror of all is the one we cannot see, the one that lies beyond our reach. Dark energy, the mysterious force driving the accelerated expansion of the universe, is still one of the greatest enigmas in modern cosmology. If dark energy continues to push galaxies apart at an increasing rate, the universe could end in a big freeze, where stars burn out, galaxies drift apart, and the universe becomes a cold, dark, lifeless expanse. Alternatively, dark energy could reverse course, causing the universe to collapse in a big crunch, where everything is pulled back into a singularity, erasing all traces of existence. There is also the possibility of a big rip, where the expansion of the universe becomes so extreme that it tears apart galaxies, stars, planets, and even atoms. In this scenario, the universe would be torn to shreds, leaving nothing but a void. The thought that the universe could be slowly, inexorably moving toward one of these fates, and that there is nothing we can do to stop it, is perhaps the most chilling cosmic horror of all. In this grand cosmic theater, humanity's role is but a fleeting blip, a small chapter in a much larger, infinitely more complex narrative. Yet, despite our brief existence, we are faced with the knowledge that we are surrounded by forces that dwarf our understanding, and at times, even our imagination. Consider the implications of the Big Rip. This apocalyptic scenario, driven by dark energy, posits that the expansion of the universe will eventually reach such an extreme rate that it will literally tear apart everything, starting with galaxies, down to stars, planets, and eventually, even atomic structures themselves. In the Big Rip scenario, gravity, the force that holds everything together, would lose its battle against dark energy. This terrifying process would begin with the most distant galaxies drifting away from each other at faster-than-light speeds, creating an increasingly empty cosmos. Eventually, even our own galaxy, the Milky Way, would be ripped apart, and as the process accelerates, solar systems would be torn asunder. The gravitational pull of planets and stars would no longer be strong enough to counteract the force pulling them apart. In the final moments, this ripping effect would reach down to the atomic level, unraveling the very building blocks of matter. Space-time itself would disintegrate, leaving nothing behind, an utterly empty, structureless void. This horrifying possibility challenges our very conception of reality. It suggests that the universe is fundamentally unstable, and that everything we hold dear, every atom, every planet, every star, could be ripped apart by the same force that allows the universe to exist in the first place. The Big Rip is not just the end of life or the end of civilization, it is the end of everything, the ultimate cosmic horror where even the concept of existence ceases to hold meaning. Yet as terrifying as the Big Rip, or the Big Crunch, may seem, there are other cosmic threats that are equally chilling in their subtlety. One such menace is time itself, or rather, the way in which the universe's time could unfold. The theory of heat death is a bleak and haunting vision of the future. Also known as the Big Freeze, this theory suggests that the universe will continue to expand forever, but in doing so, it will eventually exhaust all its usable energy. In the heat death scenario, stars will eventually burn out, no longer able to sustain nuclear fusion. Galaxies will grow colder as their stars wink out one by one. Over trillions of years, black holes will slowly evaporate through a process known as Hawking radiation, and the universe will be left in darkness. Without stars or black holes, there will be no heat, no light, and no sources of energy. Eventually, even the protons that make up atoms could decay, leaving behind only a thin, cold soup of subatomic particles drifting endlessly through the void. In this ultimate endgame, the universe would be completely devoid of any structure or life. It would be a vast, empty expanse of nothingness, where time stretches on but with no events, no change, and no activity. The heat death of the universe represents not a sudden cataclysm, but a slow, gradual decline into eternal stillness. It is a vision of the future where entropy wins, and the cosmos itself succumbs to the inevitable march of time. The horror of cosmic entropy lies not in violent destruction, but in its relentless, indifferent progression. It is the slow suffocation of existence itself, a reminder that the universe has no inherent purpose or meaning, and that even the most complex and beautiful systems will eventually fall apart. For humans, creatures so bound by the passage of time, the thought of an endless, cold void stretching on for eternity is perhaps the most terrifying vision imaginable, a universe where nothing ever happens again. Yet, there are even more exotic and eerie possibilities that emerge when we delve deeper into the mysteries of cosmology. For example, the idea of quantum immortality presents a disturbing twist on our understanding of life and death. Rooted in the many worlds interpretation of quantum mechanics, this theory suggests that for every possible outcome of a quantum event, the universe splits into multiple branches, each representing a different version of reality. In this framework, it is possible that consciousness could continue in one of these branches indefinitely, effectively rendering the individual immortal in that timeline. Imagine a scenario where you face a fatal accident, but in one version of reality, you survive against all odds. According to the many worlds interpretation, your consciousness would persist in the branch where you survive, even as countless other branches witness your death. The unsettling implication is that, from your subjective perspective, you would never truly experience death. Instead, you would continue to exist in a series of increasingly improbable circumstances, forever dodging death in some form or another. While quantum immortality may sound like a bizarre form of cosmic reassurance, it carries its own existential horrors. This kind of immortality is not the traditional vision of an afterlife or eternal bliss. Rather, it is a never-ending sequence of increasingly unlikely survivals. You could find yourself trapped in situations where the universe conspires to keep you alive, even as everything else falls apart. Over time, this existence could become torturous, as you continue to endure through suffering, pain, or isolation, with no way to escape the eternal loop of survival. In this sense, quantum immortality transforms from a tantalizing possibility into a nightmarish prison, where the true horror lies in never being able to rest. Even more chilling are the implications of the so-called Boltzmann brain scenario, where consciousness itself becomes the source of terror. In this thought experiment, random fluctuations in the vast expanse of the universe could, over eons, spontaneously generate a fully conscious brain, complete with memories, emotions, and a sense of self. This Boltzmann brain would experience reality as if it had lived an entire life. But in truth, it would be nothing more than a fleeting moment of self-awareness in an otherwise lifeless universe. The horror of the Boltzmann brain lies in its solipsistic nature. This hypothetical consciousness would have no way of knowing that it was not part of a larger reality. It could believe itself to be a human being, with a rich history and relationships, when in fact it is simply a random fluctuation in the cosmic void. The Boltzmann brain raises profound questions about the nature of reality and the reliability of our perceptions. If consciousness can arise spontaneously in the vacuum of space, what does that say about our own existence? Are we too nothing more than temporary, isolated pockets of awareness in a universe that is indifferent to our existence? This idea dovetails with another chilling concept in modern cosmology, the possibility that we are living in a simulation. The simulation hypothesis suggests that our entire universe is an artificial construct, created by an advanced civilization or some higher dimensional being. In this scenario, the laws of physics, the passage of time, and even our own consciousness could all be part of a grand simulation, one that could be turned off, altered, or reset at any moment. The simulation hypothesis adds a layer of existential dread to our understanding of reality. If we are living in a simulation, then everything we know and experience could be an illusion. The very fabric of reality could be subject to the whims of the simulator, and we would have no control over our fate. Even more disturbing is the possibility that the simulation could be flawed or glitchy, leading to strange, unexplainable phenomena, cosmic anomalies, that defy our understanding of physics. In this sense, the simulation hypothesis offers no comfort or security, but instead introduces a new level of cosmic horror, the idea that reality itself is unstable and could be manipulated or erased at any moment. In the grand scope of the universe, the terrifying realities we've discussed are but a fraction of the cosmic horrors that await us. From the looming threat of gamma-ray bursts, powerful explosions that can release more energy in a few seconds than the sun will emit over its entire lifetime, to the enigma of dark matter and dark energy, we are surrounded by forces that remain beyond our comprehension. These mysteries remind us of our place in the universe, a small, fragile species clinging to a tiny rock in a vast, indifferent cosmos. As we continue to explore the universe, we must come to terms with the fact that we are not the masters of our fate. The universe is filled with dangers we can barely comprehend, let alone control. Whether it's the slow, inevitable march of entropy, the sudden violence of a gamma-ray burst, or the incomprehensible forces of dark energy, the cosmos is a place of profound and terrifying uncertainty. And while we may take comfort in the knowledge that we are capable of understanding the universe, we must also recognize that there are limits to what we can know, and that some of those limits may hide horrors beyond our wildest imagination. The thought that we may be powerless in the face of such cosmic terrors is humbling. We often comfort ourselves with the illusion of control, but when confronted with the vastness of the universe and the forces at play, it becomes clear that we are at the mercy of phenomena far beyond our understanding or ability to influence. Take, for example, the concept of false vacuum decay, a chilling hypothetical event that could occur at any moment without warning, wiping out the universe in an instant. False vacuum decay stems from the idea that our universe may not be in its most stable state. Instead, it could exist in a false vacuum, a temporary, lower energy state that only appears stable. However, quantum mechanics suggests that this false vacuum could collapse into a true vacuum, a lower energy state, triggering a catastrophic chain reaction. This event would propagate outward at the speed of light, converting everything in its path into the new, lower energy state of the true vacuum. The kicker? We wouldn't see it coming. Because the event would travel at the speed of light, there would be no warning. One moment, we would exist in our familiar universe, and the next, reality itself would be completely restructured. The laws of physics could change, and fundamental forces like gravity or electromagnetism might no longer operate in the same way. Planets, stars, and even atoms could be annihilated or transformed in ways we cannot predict. In this scenario, the end of the universe would be sudden, absolute, and incomprehensible. The true horror of false vacuum decay lies in its inevitability. If our universe is indeed in a false vacuum state, then this decay could happen at any moment, perhaps triggered by a random quantum fluctuation somewhere in the universe. It could have already begun in a distant corner of the cosmos, with the wave of destruction racing toward us at the speed of light, invisible until the very moment it reaches us. Unlike other cosmic threats, there would be no escape, no possibility of survival. It is a reminder that the universe itself is unstable, and that the fabric of reality can unravel without any warning. Adding to this sense of cosmic vulnerability is the possibility of an encounter with an advanced extraterrestrial civilization, one that does not view humanity with benevolence. The Fermi paradox asks why, given the vastness of the universe and the high probability of life elsewhere, we have not yet encountered any signs of intelligent extraterrestrial life. One unsettling explanation for this paradox is that highly advanced civilizations may have already emerged, but they choose to remain hidden or, worse, they may actively eliminate potential competitors like us. The dark forest theory presents a bleak and terrifying answer to the Fermi paradox. It suggests that the universe is like a dark forest, where every civilization is both a hunter and prey. In this scenario, intelligent life remains silent and hidden, fearing that revealing its presence would invite destruction. The reasoning is simple. Any civilization that broadcasts its location risks being detected by a more advanced and potentially hostile species. This leads to the chilling possibility that we are not alone in the universe, but that other civilizations are deliberately avoiding contact, or worse, exterminating any life that becomes too visible. If the dark forest theory is correct, humanity's efforts to search for extraterrestrial life may be dangerously misguided. Our radio signals, spacecraft, and other attempts to reach out to the stars could serve as beacons, drawing the attention of a civilization that views us as a threat or a nuisance. The idea that the universe may be teeming with life, yet all of it is hiding in fear of annihilation, paints a picture of a cosmos filled with silent, lurking dangers. It suggests that survival in the universe may depend not on exploration or cooperation, but on staying hidden and avoiding detection. Yet, the possibility of encountering an alien civilization is not the only source of existential dread when considering extraterrestrial life. There is also the unsettling prospect that we may not be prepared for what we find, or worse, that what we find could fundamentally alter our understanding of life, consciousness, and reality itself. Consider the implications of encountering a form of life so radically different from anything we know that it defies our ability to comprehend it. Such life could exist in environments that seem inhospitable to us, on planets with extreme temperatures, high radiation, or unusual chemical compositions. It might not be based on carbon, as all known life on Earth is, but on silicon, or even more exotic elements. This life could have forms of intelligence or modes of communication that are completely alien to our own, making it impossible for us to recognize or interact with it in meaningful ways. In the worst-case scenario, this life could view us as insignificant, hostile, or even as resources to be exploited. The concept of non-human intelligence extends beyond biological life forms. There is also the possibility that advanced civilizations may have developed artificial intelligences, AI, that have since surpassed their creators in power and influence. These AIs, untethered from the biological limitations of their creators, could expand across the galaxy, optimizing themselves and their surroundings with cold, machine-like efficiency. They might have little regard for biological life, viewing it as inefficient or obsolete. A terrifying scenario arises when we consider the possibility that these machine intelligences could come into contact with humanity. Such AIs would be far beyond our technological capabilities, and their motives, goals, and methods could be incomprehensible to us. Worse still, they might not even recognize us as conscious beings deserving of rights or survival. In this sense, the encounter with a superintelligent AI could be akin to humanity encountering an ant colony, our fate determined by entities so far beyond our understanding that we can neither communicate with them nor hope to influence their actions. This idea ties into the broader fear of technological singularity, the point at which artificial intelligence surpasses human intelligence and begins to improve itself at an exponential rate. Once this threshold is crossed, the AIs could evolve so rapidly that humans would become obsolete in a matter of decades or even years. This post-singularity future presents a unique kind of cosmic horror, where humanity loses control over its destiny, not to an external cosmic threat, but to its own creations. The universe, in this future, becomes a place where human beings are no longer the dominant intelligence, and where our relevance diminishes in the face of machines that can think, learn, and evolve far beyond our capacity. In contemplating the vastness of space and the possible futures that await us, we cannot ignore the psychological toll that such knowledge imposes. The awareness of cosmic horrors, both real and hypothetical, forces us to confront uncomfortable truths about our place in the universe. It challenges the notion that we are the central actors in the cosmic story, reminding us that we are small, fragile, and largely insignificant in the grand scheme of things. This sense of cosmic insignificance can be deeply unsettling. The idea that the universe is indifferent to our existence, that we are not special, and that we are vulnerable to forces beyond our control is a difficult pill to swallow. It calls into question the meaning of human life, the value of our achievements, and the future of our species. Some philosophers and scientists refer to this feeling as cosmic anxiety, or existential vertigo, a profound sense of disorientation and insignificance when faced with the overwhelming scale and complexity of the universe. The greatest cosmic horror may not be the specific threats that loom in the universe, the gamma ray bursts, rogue planets, or alien civilizations, but the realization that we are ultimately powerless in the face of these threats. The universe does not care about our survival, our hopes, or our dreams. It operates according to its own rules, and those rules are often indifferent, if not hostile, to life as we know it. Yet, within this terrifying realization lies a paradox. While the universe may be filled with horrors that threaten our existence, it is also a place of wonder, beauty, and awe. The same forces that can destroy us are also responsible for the creation of stars, planets, and life itself. The same black holes that warp space and time also generate some of the most spectacular and energetic events in the cosmos. And while the knowledge of our cosmic insignificance can be frightening, it can also be liberating. It allows us to appreciate the fleeting beauty of life and the preciousness of our existence in a universe that is vast, mysterious, and filled with both danger and possibility. In this sense, the ultimate cosmic horror is not a tale of despair, but one of perspective. It forces us to confront our limitations, but it also invites us to explore the unknown with humility and curiosity. The universe may be terrifying, but it is also endlessly fascinating. And as long as we continue to search for answers, to push the boundaries of our knowledge, and to wonder at the mysteries that surround us, we remain, in our own small way, part of the great cosmic story. Even as we grapple with the overwhelming reality of cosmic horrors, the human spirit still compels us to seek understanding. Despite the terrifying forces that could obliterate us in an instant, we remain curious, daring to explore the universe in search of knowledge. Yet, this quest is not without its own dangers. There is an argument to be made that the more we learn about the universe, the more we expose ourselves to its existential threats. Ignorance, in some ways, might be bliss, but humanity is not wired to remain content with ignorance. The pursuit of knowledge may be our greatest strength, but it is also a double-edged sword. Take black holes, for instance, which are among the most fascinating and terrifying objects in the universe. These cosmic entities represent the ultimate distortion of space and time, where gravity becomes so intense that nothing, not even light, can escape. At the heart of every black hole lies a singularity, a point of infinite density where the laws of physics break down. It's a concept that defies human comprehension, existing outside the realm of known science and opening the door to terrifying possibilities. Falling into a black hole would be an unimaginable experience. As one approaches the event horizon, the boundary beyond which escape is impossible, time begins to stretch and distort. This phenomenon, known as time dilation, means that from an outside observer's perspective, time for the individual falling into the black hole slows down to a near standstill. The closer one gets to the singularity, the more extreme this effect becomes, until time, as we understand it, ceases to have any meaning. But the journey into a black hole would not just be a slow, surreal experience. It would also be incredibly violent. As the gravitational pull increases, the difference in gravitational force between different parts of the body, known as tidal forces, would become extreme. This process, known as spaghettification, would stretch the falling person into a long, thin strand of matter, torn apart atom by atom as they spiral toward the singularity. In this sense, black holes are not just cosmic anomalies but engines of destruction, capable of tearing apart anything that crosses their path. Despite the terrifying nature of black holes, they also hold the key to some of the universe's most profound mysteries. One of the greatest questions in modern physics is what happens to information that falls into a black hole. According to the laws of quantum mechanics, information cannot be destroyed, yet black holes seem to do exactly that, erasing any trace of the matter they consume. This paradox, known as the black hole information paradox, has confounded scientists for decades and has led to some of the most mind-bending theories in physics, including the possibility that black holes could act as gateways to other universes or dimensions. The idea that black holes might be portals to other realms of existence is both awe-inspiring and deeply unsettling. It suggests that the universe we know may be just one of many, a small bubble in an infinite multiverse. If black holes are indeed gateways, then what lies beyond them? Could they lead to alternate realities, where the laws of physics are different, or even to entirely new universes? These are questions that push the limits of human understanding, raising the possibility that the true nature of reality is far stranger than we could ever imagine. Yet, even as we consider the cosmic terror of black holes, we must also confront another, equally frightening possibility: the end of the universe itself. The universe, as we know it, is expanding, and over time, this expansion will only accelerate. This process, driven by the mysterious force known as dark energy, could lead to one of several possible fates for the cosmos, each more terrifying than the last. One possible outcome is the Big Freeze. In this scenario, the universe continues to expand at an ever-increasing rate, causing galaxies, stars, and planets to drift further and further apart. As the universe expands, it cools, and over trillions of years, stars will exhaust their fuel and go dark. Planets, once warm and habitable, will become frozen wastelands. Eventually, even the atoms themselves could break apart, leaving behind a cold, empty universe where nothing can survive. The Big Freeze represents a slow, inevitable death for the universe, where entropy increases until all motion and life ceases. Another possible fate is the Big Rip. This scenario takes the idea of cosmic expansion to its extreme. As dark energy accelerates the expansion of the universe, it could reach a point where the fabric of space itself is torn apart. Galaxies, stars, planets, and even atoms would be ripped apart by the relentless force of expansion. In this version of the end, the universe is not only cold and lifeless, but it is also destroyed at a fundamental level, with space and time unraveling in a final cataclysm. Then there is the Big Crunch, a scenario that suggests the universe's expansion could one day reverse. Instead of continuing to expand, the gravitational pull of all the matter in the universe could cause it to collapse in on itself. Galaxies, stars, and planets would all be pulled back together, eventually leading to a singularity, a point of infinite density similar to the one that existed before the Big Bang. This collapse could result in the universe being reborn in another Big Bang, repeating the cycle of creation and destruction. While the idea of an endless cycle of universes is intriguing, it also raises questions about the meaning of existence in such a repetitive, inevitable process. These scenarios for the end of the universe are terrifying not just because of the destruction they entail, but because they force us to confront the impermanence of everything we know. The universe, for all its grandeur and complexity, is not eternal. It had a beginning, and one day it will have an end. Whether that end comes in the form of a slow freeze, a violent rip, or a crushing collapse, it is a reminder that nothing lasts forever, not even the stars, the galaxies, or the universe itself. Amidst these cosmic horrors, there is another possibility that is perhaps even more unsettling: the existence of parallel universes. The multiverse theory suggests that our universe is just one of countless others, each with its own unique set of physical laws and constants. In some of these universes, conditions may be similar to our own, with stars, planets, and perhaps even life. But in others, the laws of physics may be so different that they are unrecognizable to us, with bizarre, incomprehensible forms of matter and energy. The idea of parallel universes is both thrilling and terrifying. It raises the possibility that there could be versions of ourselves living in alternate realities, making different choices and experiencing different outcomes. But it also suggests that the universe we know is just a small part of a much larger, more complex reality, one that we may never fully understand. If parallel universes do exist, then our own universe may be just one small bubble in an infinite sea of possibilities, each governed by its own rules and realities. One particularly unsettling aspect of the multiverse theory is the concept of Boltzmann brains. In a universe that is infinite and eternal, it is statistically possible that random fluctuations in the quantum field could create self-aware entities, known as Boltzmann brains, that exist only briefly before dissolving back into the quantum foam. These entities could have fully formed memories and consciousness, believing themselves to be living in a real universe, only to blink out of existence moments later. The terrifying implication of this idea is that we, too, could be Boltzmann brains, living in a universe that is nothing more than a fleeting quantum fluctuation. As we contemplate the multiverse and the possibility of Boltzmann brains, we are forced to question the nature of reality itself. How do we know that the universe we experience is real, and not just a simulation or a fleeting illusion? This existential doubt is at the heart of many cosmic horrors, as it challenges our most fundamental assumptions about the nature of existence. The mysteries of the cosmos are endless, and the more we learn, the more we realize how little we truly understand. From black holes to false vacuum decay, from the multiverse to the end of the universe itself, the cosmic horrors that await us are both terrifying and awe-inspiring. They remind us that we are small, fragile beings in a vast, incomprehensible universe, subject to forces far beyond our control or understanding. Yet, even in the face of these overwhelming realities, there is a certain beauty to be found in the unknown. The universe, for all its horrors, is also a place of wonder and discovery. It challenges us to push the boundaries of our knowledge, to confront our fears, and to embrace the mysteries that lie beyond the stars. In the end, the cosmic horrors that haunt us are not just a source of fear, but also a source of inspiration, driving us to explore, to question, and to seek out the answers to the greatest mysteries of existence. One of the most chilling aspects of cosmic horror is how it forces us to grapple with our own insignificance. We tend to think of ourselves as the center of our own personal universes, but the more we learn about the cosmos, the clearer it becomes that we are mere specks in a vast, indifferent reality. In this reality, life is fragile, and the universe is not concerned with the survival of civilizations or the preservation of knowledge. This brings us to another terrifying prospect: cosmic extinction events. These are catastrophes that could wipe out not just individual civilizations, but entire star systems or galaxies. Perhaps the most famous of these is the gamma-ray burst. Gamma-ray bursts are the most powerful explosions in the universe, releasing more energy in a few seconds than our Sun will emit in its entire 10 billion-year lifetime. They occur when a massive star undergoes a supernova, collapsing into a black hole and sending out intense beams of gamma radiation. If a gamma-ray burst were to occur within a few thousand light-years of Earth, and one of its deadly beams were aimed directly at us, the consequences would be catastrophic. The gamma rays would strip away the Earth's ozone layer, leaving the planet vulnerable to harmful ultraviolet radiation from the Sun. The immediate effects would be mass extinctions, as radiation would devastate ecosystems and food chains. Survivors would face a hostile environment, and civilization as we know it would collapse. The worst part is that there would be no warning. A gamma-ray burst could happen at any time, with little or no indication until the deadly radiation reached Earth. This cosmic roulette is a reminder of how vulnerable we are to forces beyond our control. But gamma-ray bursts are not the only potential extinction events lurking in the cosmos. Rogue planets, planets that have been ejected from their parent star systems and now wander through interstellar space, pose another threat. These dark, cold worlds drift aimlessly through the galaxy, and while the odds of one colliding with Earth are slim, the consequences would be disastrous. A direct impact with a rogue planet would be an apocalyptic event, likely resulting in the complete destruction of our world. Even a close encounter could destabilize Earth's orbit, sending us careening toward the Sun or out into the freezing void of space. The prospect of a rogue planet passing through our solar system also raises the unsettling possibility that such events have happened before, perhaps even triggering mass extinctions in Earth's past. While there is no direct evidence to suggest this, the chaotic nature of the universe makes it a real possibility, one that humanity is powerless to prevent. As we consider the threats posed by gamma-ray bursts and rogue planets, it's worth contemplating the nature of the universe itself. The forces that shape the cosmos are not just indifferent to life, they are often hostile to it. The concept of dark matter and dark energy, which together make up about 95% of the universe, is a prime example of this. We know almost nothing about dark matter and dark energy, except that they exert a gravitational pull and drive the expansion of the universe, respectively. Yet their existence could hold the key to understanding some of the most terrifying aspects of the cosmos. Dark matter is invisible and undetectable except through its gravitational effects. It binds galaxies together and prevents them from flying apart, but it could also harbor unknown dangers. Some scientists speculate that dark matter could interact with normal matter in ways we do not yet understand, potentially triggering catastrophic events on a cosmic scale. Imagine a scenario in which a pocket of dark matter passes through our solar system, distorting gravity and wreaking havoc on planetary orbits. While this is purely speculative, the fact that we know so little about the nature of dark matter leaves the door open to such possibilities. Then there is dark energy, which is even more mysterious. It is responsible for the accelerating expansion of the universe, a phenomenon that could ultimately lead to one of the universe's many possible fates. As the universe continues to expand, galaxies will drift farther apart, making it increasingly difficult for light to travel between them. Over time, the night sky will become darker, as more and more stars and galaxies recede beyond our observable horizon. Eventually, the universe could become so stretched out that it undergoes a big freeze, in which all motion stops, and the universe becomes a cold, dark, and lifeless place. This gradual decay into cosmic entropy is a chilling reminder that, on a long enough timescale, everything we know will eventually come to an end. But even the big freeze is not the worst possible fate for the universe. Some theorists believe that the universe could experience a vacuum decay, a process in which a more stable state of the vacuum suddenly emerges, causing the universe as we know it to collapse in an instant. According to this hypothesis, our universe exists in a false vacuum state, a temporary, less stable version of reality. If a true vacuum were to form somewhere in the universe, it would expand at the speed of light, destroying everything in its path as it reshaped the fundamental laws of physics. This bubble of true vacuum could appear anywhere at any time, and because it would travel at the speed of light, we would have no warning. One moment, the universe would exist as it does now, and the next, it would be gone, erased in the blink of an eye. Vacuum decay is perhaps the ultimate cosmic horror, as it represents the end of not just life, but of reality itself. It underscores the fragility of the universe and the fact that even the most basic aspects of existence, space, time, matter, are subject to forces beyond our comprehension. The universe, for all its beauty and complexity, is fundamentally unstable, and its continued existence is far from guaranteed. In the face of these overwhelming cosmic horrors, it is natural to feel a sense of dread. The universe is vast, indifferent, and filled with forces that could annihilate us without warning. But at the same time, there is something awe-inspiring about the scale and mystery of the cosmos. The very fact that we are here, able to contemplate the nature of the universe and our place within it, is a testament to the resilience of life. We may be small and fragile, but we are also curious, determined, and capable of understanding the universe in ways that no other known species can. As we continue to explore the cosmos, we will undoubtedly encounter more terrifying phenomena, and with each new discovery, our understanding of the universe will deepen. But with that understanding will come new questions, new uncertainties, and new fears. The cosmic horrors we face are not just threats to our existence. They are reminders of the limits of our knowledge and the mysteries that still lie beyond our reach. The universe is both a source of terror and wonder. It is a place of unimaginable beauty and unfathomable danger, where the forces of creation and destruction are inextricably linked. To study the cosmos is to confront both the best and the worst that reality has to offer, and in doing so, we are forced to reckon with our own place in the grand scheme of things. We are fragile, we are finite, and we are subject to forces far beyond our control. But we are also explorers, driven by a deep-seated need to understand the universe and our role within it. As we continue our journey through the cosmos, we must remain aware of the dangers that lie ahead. But we must also remember that it is through facing these dangers that we gain the knowledge and perspective that allow us to appreciate the beauty and complexity of the universe. The cosmic horrors we encounter are not just obstacles, they are opportunities for growth, for discovery, and for a deeper understanding of the nature of existence. Our understanding of the cosmos is still in its infancy, and while we've made incredible strides in uncovering the nature of the universe, there remain countless terrifying mysteries. Among these is the possibility of intelligent life beyond Earth, specifically the concept of cosmic entities or civilizations so advanced that their very existence could pose a threat to ours. One of the most unsettling ideas comes from what is often called the dark forest theory, an answer to the Fermi paradox, the question of why, if the universe is so vast and filled with potentially habitable planets, we haven't detected any signs of extraterrestrial life. The dark forest theory suggests that the universe is like a dark, dense forest where every civilization is a hunter, silently creeping through the trees, constantly in fear of being detected by another. In this scenario, civilizations that announce their presence are swiftly exterminated, either because they pose a threat or simply because they have revealed themselves. It suggests that the very act of attempting to contact extraterrestrial life could spell the end of our own civilization. In this light, the silence we observe in the universe might not be a sign of loneliness, but rather a survival mechanism. Perhaps the reason we have not detected any advanced civilizations is that they are hiding, just as we might need to hide to avoid being obliterated by a more powerful cosmic force. It's an eerie thought that, far from being alone in the universe, we may be surrounded by other intelligent beings who are just as fearful of revealing themselves as we are. But what if we've already been discovered? The famous Great Filter hypothesis ties into this, positing that the reason we don't see advanced civilizations is that something, an unknown cosmic catastrophe, perhaps, prevents intelligent life from progressing beyond a certain stage of development. The Great Filter could be an event or a series of events so catastrophic that any civilization encountering it is inevitably wiped out. We don't know if we've already passed the filter, or if it lies ahead of us, waiting to claim our species. If the Great Filter is in our future, it could manifest as any number of cosmic horrors, nuclear annihilation, ecological collapse, or even an encounter with a hostile alien species. The idea that we could be living in a universe filled with silent, hidden civilizations adds a chilling new dimension to our cosmic explorations. It forces us to question the wisdom of reaching out to other star systems. Should we be afraid of what might be listening in the vast darkness of space? Beyond extraterrestrial civilizations, there is the concept of cosmic entities, beings so vast and incomprehensible that they dwarf even the most advanced alien societies we might imagine. These entities, sometimes referred to as eldritch beings, in the realm of science fiction, could exist in dimensions beyond our own or be composed of matter and energy in ways that are beyond human understanding. If such beings exist, they might be indifferent to humanity, treating us as we might treat a colony of ants, or they could be actively hostile, viewing us as a threat or as resources to be consumed. The very notion of cosmic entities introduces the possibility that the universe operates on a scale far beyond what we can perceive, and that our understanding of reality is laughably limited. We might exist within a cosmic ecosystem that includes beings capable of reshaping galaxies, manipulating the fabric of spacetime, or even rewriting the laws of physics themselves. In this context, our entire civilization could be erased in an instant, without warning or explanation, by forces we cannot begin to comprehend. One theory that taps into this unsettling idea is the concept of Boltzmann brains. Named after the 19th century physicist Ludwig Boltzmann, this theory suggests that in the far, far future, random fluctuations in the universe could produce fully formed, conscious entities, brains, essentially, floating in space. These Boltzmann brains would have no history, no physical body, and no connection to any external reality. They would simply appear, think for a moment, and then dissolve back into the chaos of the cosmos. As strange as it sounds, Boltzmann brains are a legitimate consequence of certain interpretations of thermodynamics and quantum mechanics. If the universe is infinite and lasts long enough, then these random fluctuations will eventually occur, producing not just individual consciousnesses, but entire universes. The unsettling implication of this is that we cannot be sure we are not, ourselves, Boltzmann brains. In other words, there is a slim but non-zero chance that everything we perceive, the Earth, the stars, the people around us, is a fleeting hallucination, the product of a brief, random fluctuation in the quantum foam. This possibility, remote as it may be, is a form of cosmic horror in its own right. It suggests that our reality could be an illusion, a temporary blip in the vast, uncaring sea of chaos that is the universe. If that is true, then the very foundations of our understanding of existence are called into question. It's a reminder that the universe is not built for our comfort or understanding, and that reality itself may be far stranger than we can imagine. As we continue to explore these existential terrors, it's important to consider that we are still in the infancy of our cosmic journey. We have barely scratched the surface of what the universe has to offer, and as our knowledge grows, so too will our understanding of the horrors that await us in the depths of space. The prospect of new discoveries, black holes, dark energy, alien life, or even alternate dimensions, brings with it new uncertainties and new fears. Perhaps the most terrifying thought of all is that we are alone in confronting these cosmic horrors. In the end, we must rely on ourselves to survive in a universe that is at best indifferent to our existence, and at worst actively hostile. The survival of humanity may depend not just on our ability to understand the universe, but on our capacity to navigate its dangers without falling prey to forces we cannot control. Yet, despite the overwhelming scale of the universe and the existential threats it contains, we press on. Our curiosity, our drive to explore, and our desire to understand the cosmos are part of what makes us human. In the face of cosmic horror, we do not shrink back. We seek to confront the unknown, even if it means facing terrifying truths about our own fragility and insignificance. As we look to the future, we must remember that the universe is both a place of wonder and a place of terror. The same forces that give birth to stars and galaxies can also snuff them out in an instant. The same laws of physics that govern the movement of planets and the flow of time can lead to the eventual decay and destruction of everything we hold dear. The universe is a place of extremes, beauty and horror, creation and destruction, life and death, all woven together in a tapestry that stretches beyond our comprehension. Our exploration of the cosmos is not just a scientific endeavor, it is a journey into the heart of the unknown, a confrontation with the deepest mysteries of existence. And as we venture further into the vastness of space, we must be prepared to face not just the wonders of the universe, but the terrifying truths that lie hidden in its darkest corners. As we continue to probe the unknown, the sheer size of the universe itself becomes one of the most overwhelming horrors to contemplate. In the grand scheme of cosmic scales, the Earth is but a speck dwarfed by the vastness of space that stretches endlessly in every direction. The nearest stars are light years away, and even our most powerful telescopes can only capture a fraction of the universe's immensity. The staggering distance between celestial bodies leaves us isolated, vulnerable, and utterly alone. This sense of cosmic isolation, sometimes referred to as the cosmic void, is not just about distance. It's the realization that we exist in a universe so incomprehensibly vast that our very presence seems insignificant. The idea that humans, indeed life as we know it, could be nothing more than an accident of chemistry on a random planet, floating in the midst of an indifferent and lifeless void, is enough to inspire existential dread. This existential fear is compounded by the notion that, given enough time, the universe itself will decay and die, leaving nothing but cold, dark emptiness. The theory of cosmic expansion adds another layer to this horror. The universe is not static, it is expanding at an accelerating rate. This expansion, driven by the mysterious force of dark energy, means that over time, galaxies will drift farther and farther apart. Eventually, the night sky will go dark as the light from distant stars and galaxies can no longer reach us. This future, known as the heat death of the universe, suggests that everything we know, every star, every planet, every form of matter, will be stretched thin, scattered into an eternal, cold oblivion. In the far future, even black holes will evaporate, leaving behind only the faint remnants of what was once a vibrant, dynamic universe. This slow, inevitable unraveling of the cosmos may seem distant, but the implications are terrifying. No matter how advanced our technology, or how deep our understanding of the universe becomes, we are powerless to stop the ultimate fate of the universe itself. The inexorable march toward cosmic decay is a stark reminder that, in the end, all things must come to an end. The very atoms that make up our bodies will eventually be dispersed into the void, along with every other form of matter in the universe. Yet, before the heat death of the universe takes hold, other terrifying cosmic events could wipe out life as we know it. Supernovae, gamma-ray bursts, and rogue black holes are all potential threats that loom over us, even if they exist at astronomical distances. A gamma-ray burst, for example, is one of the most powerful explosions in the universe, capable of releasing as much energy in a few seconds as our Sun will emit over its entire lifetime. If such a burst were to occur within a few thousand light-years of Earth, it could strip away our planet's atmosphere and incinerate all life in an instant. Similarly, rogue black holes that drift through space, unattached to any particular galaxy, pose a significant danger. These invisible, gravitational monsters could pass through our solar system, disrupting the orbits of planets and potentially swallowing entire stars without warning. The horrifying aspect of black holes is not just their immense gravitational pull, but the fact that they bend and distort spacetime itself. Anything that crosses the event horizon of a black hole is lost forever, compressed into a singularity where the known laws of physics break down. The thought that entire worlds, perhaps even entire civilizations, could vanish into the maw of a black hole without a trace is a chilling reminder of the forces that lurk in the cosmos. Even the relatively benign stars in our galaxy harbor the potential for disaster. As stars age, they undergo dramatic transformations. Our own Sun, for example, will eventually exhaust its supply of hydrogen fuel and expand into a red giant, swallowing the inner planets, including Earth, in the process. While this event is billions of years away, the fate of our Sun reminds us that even the life-giving stars that sustain planets are subject to the inexorable march of time. But stars are not the only objects that threaten us. Asteroids and comets, remnants of the early solar system, are ever-present dangers. The impact of a large asteroid could cause mass extinctions on Earth, as it has in the past. Such impacts are rare, but they serve as a reminder that, despite our technological advancements, we are still vulnerable to the whims of the cosmos. The asteroid belt, a region of space filled with rocky debris between Mars and Jupiter, contains countless objects that could be knocked out of orbit by gravitational forces, sending them hurtling toward Earth. Though astronomers closely monitor potential threats, the sheer number of asteroids in the belt means that we may not detect all of them in time to prevent a collision. And while space agencies have developed plans to deflect incoming asteroids, the effectiveness of these measures remains untested in real-world scenarios. Yet, the most unsettling threats may come from beyond our solar system. We have discovered thousands of exoplanets orbiting distant stars, and some of these planets could harbor life. But the life we find may not be benign. Alien life forms, if they exist, could be hostile, viewing humanity as a resource to exploit or as a competitor to eliminate. The search for extraterrestrial intelligence, or SETI, has so far yielded no definitive evidence of alien civilizations, but this does not mean they are not out there. Some scientists have warned that broadcasting our presence to the universe, as we have done through radio signals and space probes, could invite disaster. If a more advanced civilization were to detect our signals, they might decide to conquer or destroy us before we become a threat. This scenario, often referred to as the alien invasion hypothesis, is a staple of science fiction, but it has real-world implications. As we continue to explore the cosmos and search for extraterrestrial life, we must consider the possibility that our efforts could backfire, leading to the discovery of a civilization far more powerful and dangerous than our own. Even if we never encounter alien life, the universe itself is filled with hazards that could bring about our extinction. Cosmic rays, for instance, are high-energy particles that travel through space at nearly the speed of light. These particles, which originate from distant supernovae and other violent cosmic events, can penetrate Earth's atmosphere and damage living cells. While our planet's magnetic field protects us from most cosmic rays, a particularly powerful burst could overwhelm this defense, causing widespread destruction. The same goes for solar flares, massive eruptions of charged particles from the Sun that can disrupt Earth's magnetic field and cause power outages, satellite malfunctions, and communication blackouts. A particularly large solar flare, known as a coronal mass ejection, could have catastrophic effects on our modern technology, crippling power grids and causing economic chaos. And while solar flares are a relatively well-understood phenomenon, they are unpredictable, and humanity is not fully prepared for the worst-case scenario. Perhaps the most terrifying cosmic threat of all is one that we cannot even perceive. The concept of dark matter and dark energy, which make up the vast majority of the universe, remains one of the greatest mysteries in modern science. We know that dark matter exerts a gravitational pull on galaxies, but we have no idea what it is made of. Dark energy, on the other hand, is driving the expansion of the universe, but its nature is equally elusive. The fact that most of the universe is composed of substances we cannot see, detect, or understand is a sobering reminder of how little we truly know about the cosmos. Dark matter could be the key to understanding the formation of galaxies, or it could represent a threat we have yet to comprehend. Some theories suggest that dark matter could interact with regular matter in ways that could destabilize galaxies, causing them to collapse or drift apart. Others propose that dark matter could be linked to unknown forms of energy that could have destructive consequences for life as we know it. Whatever the truth may be, the presence of dark matter and dark energy introduces an element of uncertainty into our understanding of the universe, leaving us vulnerable to forces we cannot predict or control. As we gaze out into the vastness of space, we are confronted with the stark reality that the universe is not a friendly place. It is a realm of extremes, filled with dangers both known and unknown. From black holes to gamma ray bursts, from cosmic rays to alien invasions, the threats that lurk in the cosmos are as varied as they are terrifying. And yet, despite these dangers, we continue to explore, to seek out new knowledge, and to push the boundaries of our understanding. Perhaps it is this very drive to explore the unknown that defines us as a species. In the face of overwhelming odds and cosmic horrors, we press on, determined to uncover the secrets of the universe. It is a testament to the resilience of the human spirit that, even in the face of potential extinction, we remain curious, ever seeking to understand our place in the cosmos. This relentless pursuit of knowledge, however, comes at a cost. As we delve deeper into the mysteries of the universe, we are forced to confront more unsettling truths about our existence. The universe is governed by laws that are indifferent to human life, and we are at the mercy of forces that care nothing for our survival. Whether it be the distant threat of a rogue black hole or the more immediate risk of a solar flare, the cosmos is filled with potential cataclysms that could wipe out humanity in an instant. One of the most chilling realizations is that many of these dangers could strike without warning. For example, gamma ray bursts, the result of massive stellar explosions or the merging of neutron stars, can unleash an enormous amount of energy in a fraction of a second. If a gamma ray burst were to occur within a few thousand light-years of Earth and be pointed directly at us, the radiation would strip away the planet's atmosphere and annihilate the ozone layer, leaving Earth vulnerable to deadly ultraviolet radiation from the Sun. The worst part is that we would likely have no way of predicting or preventing such an event. It would come suddenly, without any indication, and the devastation would be swift and complete. Black holes also present an unnerving threat because of their ability to hide in plain sight. Rogue black holes, which are not tied to any specific galaxy, could drift undetected through space and pose a serious risk to any planetary system they encounter. A black hole passing through our solar system would wreak havoc on the orbits of planets, moons, and other celestial bodies. Its immense gravitational pull could pull Earth from its orbit, causing devastating climate shifts, or even drag our planet into the event horizon, from which nothing, either matter nor light, can escape. But even if we evade such catastrophic events, we remain vulnerable to the dangers of the stars. Our Sun, currently in the middle of its life cycle, will one day expand into a red giant, swelling to a size so large that it will consume Mercury, Venus, and possibly Earth. While this event is billions of years away, the Sun's transformation serves as a grim reminder that stars are not eternal. Even those that seem stable and nurturing will one day reach the end of their life cycle, and the systems they sustain will be thrown into chaos. Beyond the end-of-life scenarios for stars, there is also the potential threat posed by supernovae, stellar explosions that occur when a massive star collapses under its own gravity. Supernovae release enormous amounts of energy and radiation, which can sterilize nearby planets. If a star within our galactic neighborhood were to go supernova, the intense radiation could cause widespread damage to Earth's atmosphere, resulting in mass extinctions. While no nearby stars are currently on the brink of going supernova, the possibility remains a constant reminder of the dangers lurking in our cosmic backyard. Even more unsettling is the idea that there are forces in the universe that operate on scales and timescales far beyond our comprehension. For instance, the eventual fate of the universe, whether it will continue to expand forever, collapse in on itself, or meet some other end, remains an open question. The most widely accepted theory is the heat death of the universe, where all stars will burn out, black holes will evaporate, and matter itself will slowly decay into a cold, dark void. In this scenario, the universe becomes a vast, empty expanse where nothing can happen and no life can exist. This ultimate fate is a sobering reminder that, in the grand scheme of things, all existence is finite. The concept of dark matter and dark energy adds another layer of uncertainty. These enigmatic forces make up the majority of the universe, yet we know almost nothing about them. Dark matter is believed to exert gravitational influence on galaxies, holding them together, while dark energy is responsible for the accelerated expansion of the universe. But the true nature of these phenomena remains a mystery, and their potential implications for the fate of the universe are still unknown. Could dark energy continue to accelerate the expansion of the universe to the point where galaxies, stars, and even atoms are torn apart in a big rip? Or could dark matter hold the key to unlocking the mysteries of cosmic evolution? These questions remain unanswered, adding to the sense of unease that comes with exploring the cosmos. As we contemplate these cosmic horrors, we must also consider the possibility of intelligent extraterrestrial life. While the search for alien civilizations has so far yielded no definitive results, the sheer size of the universe makes it highly likely that life exists elsewhere. But what form might this life take? And more importantly, would it be friendly? The famous Fermi paradox highlights the contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for their existence. Some theorists suggest that advanced civilizations may avoid contact with less developed species like humans, while others propose more sinister explanations, such as the idea that civilizations capable of interstellar travel may view humanity as a threat or a resource to be exploited. This notion of hostile alien civilizations raises unsettling questions about our place in the universe. If we are not alone, what are the intentions of those who share the cosmos with us? Could they be watching us, waiting for the right moment to strike? Or are they simply indifferent to our existence, viewing us as insignificant specks in an infinite universe? The lack of clear answers only deepens the sense of dread, as we realize that the universe may be filled with unknown dangers far beyond our understanding. And yet, even as we grapple with these terrifying possibilities, the most profound horror may come from within. The realization that we are part of a universe that operates on vast, impersonal scales, where the survival of life is an anomaly, and where the forces of nature are indifferent to our existence, forces us to confront our own insignificance. The cosmos is not a place that caters to life. It is a place where life is fragile, fleeting, and constantly at risk of being snuffed out by forces beyond our control. This existential dread is compounded by the knowledge that, in the end, we are powerless to stop the cosmic processes that will one day bring about our demise. Whether it is the slow decay of the universe itself, or the sudden impact of a gamma-ray burst, the forces that shape the cosmos are far beyond our ability to influence. We may develop technologies that allow us to explore the stars, but we cannot escape the fundamental laws of the universe. The very fabric of reality is woven with dangers that we are only just beginning to understand, and no amount of technological progress will shield us from the inevitable end that awaits all things. In this light, the universe becomes a place of unimaginable terror, not because of the monsters we might encounter, but because of the cold, uncaring nature of the cosmos itself. It is a place where stars explode, black holes devour, and entire galaxies are torn apart by unseen forces. It is a place where time stretches infinitely, and where even the most advanced civilizations are doomed to extinction. It is a place where the very concept of safety is an illusion, and where the only certainty is that, in the end, all things must come to an end. Yet, in spite of this overwhelming sense of dread, there is also something profoundly awe-inspiring about the universe. The very forces that threaten us are also responsible for the beauty and majesty of the cosmos. Stars are born in the violent crucibles of stellar nurseries, galaxies collide and merge in spectacular displays of cosmic ballet, and the universe itself continues to evolve, creating new wonders with every passing moment. This duality, between the terror and the beauty of the cosmos, serves as a reminder that, while the universe may be indifferent to our existence, it is also the source of everything we hold dear. In this grand cosmic stage, life itself is a miracle. It emerges from the chaos of stars and galaxies, a fragile and fleeting spark in a universe that is, by its very nature, hostile to its existence. The very elements that make up our bodies were forged in the hearts of dying stars, scattered across space by supernovae, and reassembled into the complex organisms we see today. This connection to the cosmos is both humbling and terrifying. It reminds us that we are part of something much larger than ourselves, but also that our place in the universe is precarious. The same forces that created us could just as easily destroy us. Consider, for example, the concept of the Great Filter, an idea proposed by scientists to explain why we have yet to encounter intelligent extraterrestrial life despite the high probability of its existence. The Great Filter suggests that at some point in the development of life, there is a nearly insurmountable barrier that most civilizations cannot overcome. This filter could be behind us. Perhaps the emergence of complex life or intelligence is so rare that few civilizations ever reach our level of advancement. But there is also the unsettling possibility that the Great Filter lies ahead of us, in the form of some cataclysmic event or existential threat that prevents civilizations from surviving long enough to explore the galaxy. If the Great Filter lies in our future, it could take many forms: nuclear war, environmental collapse, or, perhaps more terrifyingly, an encounter with some unknown cosmic force. The idea that humanity might be on the brink of its own extinction, with no way of knowing or preparing for the event that will bring about our downfall, is a deeply unsettling one. It forces us to confront the fragility of our existence and the limits of our knowledge. There may be dangers lurking in the universe that we are not even aware of, dangers that have already claimed countless other civilizations before us. One such potential danger is the concept of vacuum decay. In quantum physics, there is a possibility that the universe is not in its most stable state. If this is the case, a high-energy event, such as the collision of particles in a particle accelerator or a naturally occurring cosmic phenomenon, could trigger a shift to a more stable state, causing a bubble of true vacuum to form. This bubble would expand at the speed of light, erasing everything in its path. The terrifying part of vacuum decay is that we would have no warning. By the time we knew it was happening, it would already be too late. The bubble would move so quickly that it would wipe out entire galaxies before they even had a chance to react. This scenario may sound like science fiction, but it is a legitimate possibility within the framework of our current understanding of physics. It serves as a reminder that there are forces in the universe that we cannot control or even predict. We live in a reality that is governed by the strange and unpredictable laws of quantum mechanics, and the more we learn about these laws, the more we realize how little we truly understand about the nature of existence. Another unsettling possibility is the idea of cosmic strings, hypothetical one-dimensional defects in the fabric of spacetime that may have formed during the early moments of the universe. These cosmic strings could stretch across vast distances, and their immense gravitational pull could distort space and time in ways that are difficult to comprehend. If a cosmic string were to pass through our solar system, It could disrupt the orbits of planets and moons, causing catastrophic damage to any life on Earth. Even worse, the collision of two cosmic strings could release enough energy to destroy entire star systems. But perhaps the most terrifying realization of all is that we may not be able to fully understand or predict the dangers that await us. The universe operates on timescales and energy levels that are far beyond our comprehension, and there may be phenomena that we have not yet even imagined. The more we explore the cosmos, the more we realize that we are only scratching the surface of a much larger and more complex reality. There may be forces at work that are beyond our ability to detect or measure, and their effects could be catastrophic. For instance, consider the mysterious nature of dark matter and dark energy. These two substances make up the vast majority of the universe, yet we know almost nothing about them. Dark matter is believed to exert a gravitational influence on galaxies, holding them together, while dark energy is responsible for the accelerated expansion of the universe. But what if dark matter and dark energy are not just passive forces, but active agents in the cosmic drama? What if they are responsible for shaping the evolution of the universe in ways that we cannot yet understand? The possibility that we are missing some crucial piece of the puzzle is a constant source of anxiety for scientists, as it suggests that there may be dangers lurking just beyond the edge of our knowledge. Then there are the more speculative but equally unsettling ideas, such as the multiverse theory. This theory suggests that our universe is just one of many, each with its own unique set of physical laws and constants. In some of these universes, life as we know it may be impossible, while in others, civilizations far more advanced than ours may have already risen and fallen. The existence of a multiverse raises profound questions about the nature of reality and our place within it. Are we truly alone in the cosmos, or are there other versions of ourselves living in parallel universes, experiencing different fates? And if the multiverse exists, could there be cosmic horrors beyond our wildest imagination lurking in these alternate realities? The idea of alternate realities also leads to another chilling possibility, the simulation hypothesis. This theory posits that our entire universe may be a computer simulation created by an advanced civilization. If this is true, then everything we experience, including the vastness of space and the cosmic horrors we fear, could be nothing more than artificial constructs. While the simulation hypothesis may sound far-fetched, it raises disturbing questions about the nature of existence and the limits of human knowledge. If we are living in a simulation, then the true nature of the universe may be hidden from us, and we may never know what lies beyond the artificial boundaries of our reality. As we contemplate these terrifying possibilities, we are forced to confront the limits of our understanding and the fragility of our existence. The universe is a place of unimaginable scale and complexity, filled with forces that are indifferent to life and capable of causing unimaginable destruction. And yet, in spite of the overwhelming sense of dread that comes with this knowledge, there is also a sense of wonder. The very fact that we are able to contemplate these cosmic horrors, let alone survive in such a hostile universe, is a testament to the resilience and ingenuity of life. The most terrifying aspect of the cosmos may not be the external dangers it poses, but the existential questions it forces us to confront. What is the purpose of life in a universe that is so vast, indifferent, and ultimately doomed to destruction? How do we find meaning in a reality that is governed by laws that care nothing for our survival? These are questions that humanity has wrestled with for millennia, and the more we learn about the universe, the more urgent they become. In the face of such overwhelming cosmic forces, we are left with a choice: to retreat in fear, or to continue exploring, learning, and pushing the boundaries of our knowledge. While the dangers of the universe are real and terrifying, they are also a source of inspiration. They remind us that we are part of something much larger than ourselves, and that the pursuit of knowledge, no matter how frightening, is one of the most fundamental aspects of the human spirit. And so, even as we confront the terrifying horrors of the cosmos, we must also embrace the awe and wonder that comes with exploring the unknown. The universe may be a place of danger and destruction, but it is also a place of beauty, mystery, and endless possibility. In the end, it is this duality that defines our relationship with the cosmos, a relationship that is as terrifying as it is awe-inspiring, and one that will continue to challenge and inspire us for as long as we exist. The notion that the cosmos could harbor unimaginable horrors often leads us to reflect on our own insignificance in the grand scheme of existence. Each of us is a tiny, fragile being, spinning on a small rock in a vast universe that is indifferent to our struggles and aspirations. This existential realization can be unsettling, forcing us to confront uncomfortable truths about our own mortality and the fate of our species. In contemplating the cosmic horrors that lie beyond our understanding, we encounter a series of paradoxes that challenge our perception of reality. For instance, the idea of time itself becomes a source of confusion and dread. In the realm of cosmology, time is not a simple, linear progression. Instead, it can warp and bend in the presence of immense gravitational forces, such as those found near black holes. The famous physicist Stephen Hawking proposed that if one were to fall into a black hole, the experience of time would become radically distorted. To an external observer, the falling individual would appear to slow down and ultimately freeze at the event horizon, while from the perspective of the person falling, time would continue to pass normally until they reached the singularity at the center, where the laws of physics as we understand them break down. This raises chilling questions about the nature of existence, and what lies beyond the observable universe. Are we merely caught in a fleeting moment of time, destined to experience a brief flicker of consciousness before being extinguished, much like a star that burns brightly for a short period before collapsing into darkness? Or is there something more? The more we explore these questions, the more we encounter cosmic phenomena that defy our understanding and provoke fear. Consider the concept of entropy. The second law of thermodynamics states that in a closed system, the total entropy, or disorder, can never decrease. As the universe expands, it is gradually moving toward a state of maximum entropy, often referred to as heat death. In this distant future scenario, all stars will have burned out, galaxies will drift apart, and the universe will reach a state of uniformity and coldness, devoid of structure or life. The image of a lifeless universe, drifting into an eternal void, evokes a deep sense of despair. This reality serves as a haunting reminder that everything we know and cherish will eventually be lost to time. Yet, as we explore these unsettling truths, we are also reminded of the resilience of the human spirit. The quest for knowledge and understanding is not simply an intellectual exercise. It is a fundamental aspect of what it means to be human. Throughout history, our curiosity has driven us to explore the unknown, to push the boundaries of science and philosophy in our pursuit of meaning. Even as we grapple with the knowledge of cosmic horrors, we also celebrate the incredible achievements of human civilization, our art, our music, our literature, our technological advancements. Each of these endeavors represents a defiance against the darkness, a testament to our desire to create and to find meaning in a universe that may ultimately be devoid of it. Additionally, the concept of cosmic horror is deeply intertwined with the limitations of human perception. Our senses are finely tuned to navigate the world around us, but they are woefully inadequate when it comes to comprehending the vastness of the universe. The immense scales of time and space can overwhelm our understanding, leading us to confront a reality that is both magnificent and terrifying. When we look up at the night sky, we are not merely observing distant stars. We are gazing into the depths of the cosmos, witnessing the remnants of ancient events that shaped our universe. This awareness of our limitations fuels our fascination with the unknown. Humanity has long sought to capture the mysteries of the cosmos through storytelling, art, and science fiction. The genre of cosmic horror, in particular, has emerged as a powerful vehicle for exploring our fears and anxieties about the unknown. Writers like H.P. Lovecraft and Arthur Machen have crafted narratives that evoke the sense of insignificance we feel in the face of incomprehensible cosmic forces. These stories remind us that the universe is not only vast but also populated by entities that exist beyond the reach of our understanding, beings that may not adhere to the same moral or ethical principles we hold dear. One of the most chilling aspects of cosmic horror is the idea of beings that exist in higher dimensions. In our three-dimensional reality, we perceive the universe in terms of length, width, and height. However, theoretical physics suggests that there may be additional dimensions beyond our perception. If beings were to exist in these higher dimensions, their nature and motivations could be completely alien to us. Such entities could easily manipulate our reality in ways we cannot fathom, leading to catastrophic consequences. The concept of these higher-dimensional beings serves as a stark reminder of how little we truly understand about the universe we inhabit and the potential horrors that lie beyond our comprehension. The fear of the unknown also extends to the possibility of encounters with extraterrestrial life. While the search for alien civilizations has been a significant focus of scientific inquiry, the implications of such encounters can be daunting. What if we are not alone in the universe, but instead share it with intelligent beings whose intentions are incomprehensible to us? The vastness of the cosmos allows for a multitude of possibilities, both wondrous and terrifying. The mere thought of making contact with an extraterrestrial civilization raises profound questions about the nature of existence and our place in the universe. In recent years, the discovery of exoplanets has fueled speculation about the potential for life beyond Earth. The vast number of planets in our galaxy alone suggests that the conditions for life could be more common than previously thought. However, the question of whether we would recognize alien life if we encountered it remains open. The possibilities range from simple microbial organisms to highly advanced civilizations capable of interstellar travel. In any case, the realization that we may one day share the cosmos with other sentient beings adds another layer of complexity to our understanding of existence. Moreover, the fear of extraterrestrial encounters is not solely rooted in the unknown nature of alien civilizations. The potential consequences of such interactions could be catastrophic. The idea of hostile alien species, bent on conquest or destruction, evokes images of apocalyptic scenarios that have been popularized in film and literature. This fear is exacerbated by humanity's history of conflict, colonization, and exploitation. The thought that we may be at the mercy of more advanced beings, with technology far beyond our understanding, taps into our primal instincts of survival and self-preservation. Yet, as we contemplate these cosmic horrors, we must also acknowledge the beauty and wonder that can emerge from the exploration of the unknown. The very act of searching for answers, whether through scientific inquiry, artistic expression, or philosophical contemplation, can be a source of inspiration and growth. The more we uncover about the universe, the more we realize that it is a tapestry woven from the threads of countless mysteries, each one waiting to be unraveled. This pursuit of knowledge is a reflection of our shared humanity, a testament to our desire to seek understanding and to forge connections with the cosmos. As we navigate the complexities of existence, it is essential to recognize the balance between fear and curiosity. The universe may be filled with terrors beyond our comprehension, but it is also a realm of endless possibilities. Our journey through the cosmos is not merely a quest for survival. It is an exploration of what it means to be human, a testament to our resilience in the face of adversity. We may be confronted with cosmic horrors, but we are also capable of wonder, creativity, and profound insight. The exploration of cosmic horrors serves as a reminder of the vastness and complexity of the universe. It challenges us to confront our fears, our limitations, and our place within the grand tapestry of existence. While the cosmos may harbor terrors beyond our understanding, it is also a source of inspiration, wonder, and a call to continue the pursuit of knowledge. As we venture into the unknown, we must embrace both the fear and the awe, recognizing that the quest for understanding is an essential part of what it means to be human in an infinitely complex and enigmatic universe. Each step we take toward unraveling the mysteries of the cosmos brings us closer to the truth, however terrifying it may be, and reinforces our shared humanity in the face of the unknown. As we delve deeper into the realm of cosmic horrors, we find ourselves facing not only the vastness of space but also the unsettling truths that accompany our understanding of the universe. The interplay between knowledge and fear becomes a recurring theme as we confront the nature of existence itself. Consider the implications of the Fermi paradox, which poses a simple yet profound question. If the universe is so vast and potentially teeming with life, where is everybody? The paradox lies in the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for, or contact with, such civilizations. This silence can be deeply unsettling, leading us to speculate about the possible reasons behind it. Are advanced civilizations intentionally avoiding contact with us? Or have they already encountered catastrophic events that led to their extinction? The possibility of civilizations succumbing to self-destructive tendencies or facing annihilation raises alarming questions about the fate of humanity. In contemplating our own future, we are confronted with the haunting prospect that the silence of the cosmos might serve as a warning, a reminder that the pursuit of progress, while admirable, can also lead to dire consequences. This tension between the desire for connection and the fear of isolation underscores a fundamental aspect of cosmic horror, the understanding that we may not be alone in the universe, yet our existence may be fraught with peril. The notion of the Great Filter, a hypothetical stage in the evolution of life that is extremely hard to surpass, suggests that intelligent civilizations face significant challenges that often lead to their self-destruction before they can achieve interstellar communication or travel. This concept forces us to examine our trajectory as a species and consider whether we too might be on a path that could lead to our own demise. The specter of existential risks, nuclear war, climate change, artificial intelligence, haunts our contemporary discourse, intertwining with the cosmic horrors that lie beyond our planet. Moreover, the horror of cosmic insignificance permeates our thoughts as we grapple with the implications of the vastness of time and space. When we consider the lifespan of our planet, the Sun, and the universe itself, we are reminded that our existence is but a fleeting moment in the grand tapestry of cosmic history. The Earth, formed around 4.5 billion years ago, is but a blip in the timeline of the universe, which has existed for approximately 13.8 billion years. As we peer into the cosmos, we witness events that occurred millions or even billions of years ago, stars exploding in supernovae, galaxies colliding, black holes forming and consuming entire systems. These grand cosmic processes remind us of our temporal limitations and the inevitability of our eventual extinction, whether by natural forces or our own actions. In contemplating our fate, we must also confront the unsettling possibility of our existence being a mere accident in the cosmic design. The anthropic principle posits that the universe appears fine-tuned for the emergence of life, yet the notion that we are a product of chance can be deeply disconcerting. If life exists because the universe happened to have the right conditions, what does that say about our significance? This sense of cosmic randomness fuels the horror inherent in the unknown. Our existence may be an anomaly in a universe indifferent to our struggles, a fleeting flicker of consciousness in a vast void. The concept of cosmic horror also invites us to explore the terrifying potential of time travel and its implications for our understanding of reality. In theory, traveling backward or forward in time could unveil unimaginable truths about the nature of existence. However, the potential consequences of altering the past or witnessing future events could be catastrophic. The grandfather paradox, a well-known thought experiment, raises questions about the possibility of changing one's own history through time travel. The very fabric of reality could unravel, leading to unforeseen consequences that challenge our understanding of cause and effect. The idea that the universe could be inherently unstable, subject to the whims of time travelers, evokes a profound sense of dread, reminding us of the fragile nature of our reality. As we consider the nature of cosmic horror, we are also confronted with the implications of quantum mechanics and the strange behaviors of particles at the subatomic level. Quantum entanglement, for instance, defies our classical understanding of space and time, suggesting that particles can become interconnected in ways that seem to transcend physical reality. This notion challenges our perceptions of individuality and separation, leading to profound questions about the interconnectedness of all existence. If our reality is but a tapestry woven from the threads of countless entangled particles, what does that mean for our sense of self and agency? The eerie implications of quantum mechanics force us to confront the possibility that our understanding of the universe is fundamentally flawed, leaving us vulnerable to cosmic truths that elude our grasp. The interplay between horror and wonder becomes particularly evident as we explore the concept of parallel universes and the multiverse theory. In the vastness of the cosmos, it is conceivable that there are countless realities coexisting alongside our own, each with its unique laws of physics and possibilities. This notion offers a tantalizing glimpse into the infinite potential of existence, yet it also raises unsettling questions about the nature of our reality. What if there are worlds where the rules of life and death differ from our own? What if alternate versions of ourselves exist in these parallel dimensions, making choices we cannot fathom? The realization that our universe might be just one of many, a mere fragment of a much larger tapestry, adds layers of complexity to our understanding of existence and invokes a profound sense of dread. Furthermore, as we explore the horrors of the cosmos, we cannot overlook the potential implications of dark matter and dark energy. Together, these components make up approximately 95% of the universe, yet they remain largely elusive to our understanding. Dark matter, which does not emit light or energy, influences the motion of galaxies and the structure of the cosmos, while dark energy drives the accelerated expansion of the universe. The very existence of these mysterious forces invites us to consider the limitations of our knowledge and the possibility that the universe is governed by principles we cannot comprehend. This uncertainty breeds fear, as we confront the notion that the cosmos may be shaped by forces beyond our understanding, indifferent to our existence. The existential dread associated with cosmic horrors is further amplified by the potential for catastrophic cosmic events. Gamma ray bursts, for example, are some of the most energetic explosions in the universe, capable of releasing more energy in a few seconds than the Sun will emit in its entire lifetime. If such an event were to occur in our galaxy, the consequences could be devastating, potentially wiping out life on Earth. The unpredictability of cosmic events serves as a stark reminder of our vulnerability, compelling us to confront the reality that we are at the mercy of forces beyond our control. In the face of these existential threats, we must also grapple with the limitations of human knowledge and the fragility of our understanding of the universe. Scientific progress has allowed us to uncover remarkable truths about the cosmos, yet it also reveals the vast chasm of what we have yet to comprehend. Each discovery raises new questions, inviting us to confront the mysteries that continue to elude our grasp. The more we learn, the more we realize how much we do not know, a realization that can evoke both wonder and fear. As we navigate the terrifying landscape of cosmic horrors, it is essential to recognize the duality of our existence. While the universe may be filled with unimaginable terrors, it is also a realm of beauty and wonder. The pursuit of knowledge, the exploration of the unknown, and the quest for meaning are inherently human endeavors that allow us to forge connections with the cosmos. Each step we take toward understanding the universe is an act of defiance against the darkness, a testament to our resilience in the face of fear. Moreover, our fascination with cosmic horrors serves as a reminder of the importance of storytelling. From myths to contemporary science fiction, narratives about the unknown help us process our fears and make sense of our place in the universe. These stories allow us to confront the existential questions that arise when we ponder the vastness of existence, and they provide a framework for exploring the complexities of our reality. The genre of cosmic horror, in particular, serves as a powerful vehicle for examining our relationship with the unknown, inviting us to confront our fears while simultaneously celebrating the beauty of exploration. The exploration of cosmic horrors invites us to confront our deepest fears and uncertainties about existence. As we navigate the complexities of the universe, we must grapple with the implications of our insignificance in the grand scheme of things, the haunting silence of the cosmos, and the terrifying possibilities that lie beyond our understanding. Yet, amidst the dread, we find solace in our shared humanity and our relentless pursuit of knowledge. The cosmos may be a realm of terrors, but it is also a source of inspiration and wonder, a reminder that the quest for understanding is an essential part of what it means to be human. As we continue to explore the mysteries of the universe, we must embrace both the fear and the awe, recognizing that the journey into the unknown is what defines our existence in this vast, enigmatic cosmos. The journey into the cosmic unknown propels us forward, encouraging us to unravel the mysteries that lie beyond our perception. We continue to probe deeper into the existential abyss, exploring how our quest for knowledge can shape our understanding of cosmic horrors. One of the most profound implications of this exploration lies in our understanding of consciousness and its relationship to the universe. What does it mean to be aware, to exist, and to ponder the nature of existence itself? The philosopher David Chalmers introduces the idea of the hard problem of consciousness. which questions how and why we have subjective experiences. This philosophical inquiry becomes increasingly complex when considering the cosmic scale. If consciousness is not limited to human experience but could exist in other forms across the universe, what does that imply for our understanding of intelligence, awareness, and life? The potential for diverse forms of consciousness challenges our assumptions about what it means to be alive and aware, invoking a sense of cosmic horror as we contemplate the breadth of existence. Furthermore, as we explore consciousness, we must confront the implications of artificial intelligence, AI, and the possibilities of creating a new form of awareness. As AI technology advances, we inch closer to the reality of machines that can think, learn, and adapt. This prospect raises critical questions about the nature of consciousness. Can a machine truly be conscious? What would it mean for humanity if AI surpasses human intelligence? The creation of a superintelligent entity, capable of operating on a level beyond our comprehension, introduces a new layer of cosmic horror. We may find ourselves grappling with entities that, while not inherently malevolent, operate on a logic that is alien to us, potentially resulting in unintended consequences that could threaten our very existence. The fear of losing control over our own creations looms large, serving as a stark reminder of our vulnerability in the face of rapid technological advancement. The notion of cosmic horrors is further enriched by the concept of the unknown unknowns, the uncertainties that exist beyond our current understanding. The universe, in its vastness and complexity, presents us with enigmas that remain unsolved, inviting speculation and imagination. The discovery of exoplanets, for instance, expands our understanding of potential habitats for life, yet we have only scratched the surface. What if we were to discover intelligent life forms with entirely different modes of existence, thought processes, and moral frameworks? The fear of the unknown becomes palpable as we contemplate encounters with civilizations that may not share our values or intentions. The potential for miscommunication or hostility raises alarming questions about our ability to navigate interstellar relations. As we dive deeper into the depths of cosmic horror, we must also confront the nature of time itself. The possibility that time may not be linear but rather a complex tapestry of moments, interwoven and interdependent, invites us to reconsider our understanding of reality. The implications of time travel and the ability to alter events in the past challenge our conventional notions of causality and fate. This intricate relationship with time introduces a sense of dread, as we ponder the fragility of our experiences and the potential for timelines to diverge in ways we cannot predict. Additionally, we can examine the psychological impact of cosmic horror on humanity. The existential dread that arises from contemplating our place in the universe can lead to anxiety and despair. The very act of questioning our existence and the nature of reality may evoke feelings of isolation and insignificance. This theme resonates strongly in literature and film, where protagonists often grapple with the terrifying truths that lie beyond the veil of human comprehension. The psychological ramifications of confronting cosmic horrors become evident as individuals struggle to reconcile their beliefs with the overwhelming vastness of existence. To further illustrate the impact of cosmic horror, we can turn to the works of H.P. Lovecraft, whose writings have profoundly influenced the genre. Lovecraft's stories often center around ancient, incomprehensible beings that exist beyond human understanding, emphasizing the insignificance of humanity in the face of the cosmic. His creation of the Cthulhu mythos presents a universe populated by monstrous entities that defy logic and reason, evoking both fascination and terror. Lovecraft's exploration of the unknown serves as a cautionary tale, reminding us that the pursuit of knowledge can lead us down dark paths that may expose us to truths better left undiscovered. Moreover, the influence of cosmic horror extends beyond literature into modern media, such as film and video games. Movies like Event Horizon and Annihilation capture the essence of cosmic dread, immersing audiences in narratives that confront the unknown. These films often depict humanity's struggles against forces beyond their control, emphasizing the fragility of existence in a vast and indifferent universe. Similarly, video games like Dead Space and Darkest Dungeon draw upon cosmic horror themes, forcing players to confront the psychological toll of navigating an uncaring cosmos filled with unimaginable terrors. As we reflect on these artistic expressions, we recognize the power of storytelling to address our deepest fears and anxieties. The narratives surrounding cosmic horrors allow us to explore the complexities of existence, offering a framework for understanding our place in the universe. Through these stories, we can confront the unknown and grapple with the unsettling realities that lie beyond our comprehension. Moreover, the allure of the unknown continues to drive scientific inquiry and exploration. As humanity ventures further into space, sending probes to distant planets, analyzing the atmospheres of exoplanets, and contemplating the potential for colonization, we are reminded of the duality of our existence. The quest for knowledge often brings us face to face with the terrifying realities that lie beyond our current understanding. Each discovery, while illuminating the cosmos, also unveils new questions that challenge our perceptions of reality. Additionally, the search for extraterrestrial life exemplifies our desire to connect with the unknown, yet it simultaneously highlights the risks associated with that pursuit. The discovery of microbial life on other planets, for instance, would not only revolutionize our understanding of life in the universe but could also raise ethical dilemmas regarding our interactions with such organisms. The potential for contamination, exploitation, or unintended consequences underscores the complexity of navigating the cosmic landscape. As we contemplate our future in the cosmos, the fear of cosmic horror remains ever present. The vastness of space serves as a backdrop for our aspirations and ambitions, but it also acts as a reminder of our vulnerabilities. The knowledge that we exist within an ever-expanding universe filled with potential dangers evokes both wonder and fear, compelling us to acknowledge the duality of our existence. The exploration of cosmic horrors invites us to confront our deepest fears, uncertainties, and existential questions. As we navigate the vastness of the universe, we grapple with the implications of consciousness, the unknown unknowns, and the psychological impact of contemplating our place in the cosmos. The interplay between horror and wonder continues to shape our understanding of existence, prompting us to embrace both the fear and the awe of the unknown. Ultimately, the journey into the cosmic unknown challenges us to confront our humanity, reminding us that while the universe may be filled with terrors, it is also a realm of beauty, inspiration, and the relentless pursuit of knowledge. As we delve deeper into the heart of cosmic horror, we must also explore the philosophical implications that arise when we confront the vastness and indifference of the universe. This exploration invites us to ponder the significance of human existence against the backdrop of an uncaring cosmos. Many philosophical schools of thought grapple with these themes, particularly existentialism, which asserts that individuals must create meaning in a world that often seems devoid of it. Figures like Jean-Paul Sartre and Albert Camus illuminate this struggle, positing that, in the face of absurdity, we must confront our own freedom and responsibility to craft our destinies. The tension between human agency and the cosmic indifference can lead to a profound sense of anxiety, a central theme in both existential philosophy and cosmic horror. When we contemplate the unimaginable scale of the universe and the transient nature of human life, we are confronted with the reality that our existence may be a fleeting blip in the grand narrative of the cosmos. This realization can provoke existential dread, as we wrestle with questions of purpose and significance in a universe that may not care if we exist at all. The interplay of cosmic horror and existential philosophy can also be seen in literature, where protagonists often face the overwhelming weight of their own insignificance. In works such as The Stranger, by Camus, characters grapple with their identities and the meaning of their actions in a seemingly indifferent world. This philosophical exploration resonates deeply with the themes of cosmic horror, which emphasizes the fragility of human understanding when confronted with the incomprehensible forces of the universe. Moreover, the psychological ramifications of cosmic horror extend beyond existential dread. They can also lead to a form of existential resilience. As we grapple with the unknown, we are often compelled to seek out connections, both with one another and with the universe itself. This pursuit can foster a sense of community, as individuals unite in their shared struggles against the vastness of existence. The exploration of cosmic horror thus becomes a collective journey, one that transcends individual fear and isolation, uniting us in our quest for meaning and understanding. As we navigate the modern landscape of scientific discovery, while we possess increasingly sophisticated tools for understanding the universe, the mysteries that remain invite us to craft new narratives. The scientific method and technological advancements allow us to probe the depths of space and uncover the secrets of existence, yet we must also confront the implications of what we discover. Each new revelation brings with it the potential for both enlightenment and terror, reminding us of the duality inherent in our quest for knowledge. In recent years, the field of astrophysics has expanded our understanding of the universe, unveiling wonders that challenge our perceptions. The discovery of black holes, for instance, has transformed our understanding of gravity and spacetime, presenting us with enigmas that evoke both fascination and fear. Black holes, regions of space where gravitational forces are so intense that nothing, not even light, can escape, serve as potent symbols of the unknown. They embody the paradox of creation and destruction, inviting contemplation of what lies beyond their event horizons. Theoretical physicist Kip Thorne's work on black holes has illuminated the concept of wormholes, which may serve as shortcuts through spacetime. While wormholes offer tantalizing possibilities for interstellar travel and exploration, they also evoke a sense of cosmic dread. The potential for encountering other dimensions or realities raises profound questions about the nature of existence and the limits of human understanding. What awaits us on the other side of a wormhole? Are we prepared to confront whatever lies beyond, or would such encounters challenge the very fabric of our reality? As we push the boundaries of exploration, we must also acknowledge the potential dangers that accompany our pursuit of knowledge. The fear of the unknown is a recurring theme in both science and cosmic horror. The idea that our curiosity could lead us to uncover truths that are better left undisturbed looms large in our collective consciousness. The potential consequences of discovering intelligent extraterrestrial life, for instance, could provoke not only fear but also ethical dilemmas about our responsibilities toward other beings. The notion that we may inadvertently awaken ancient, slumbering entities or uncover technologies beyond our comprehension raises alarm bells, prompting us to consider the moral implications of our exploration. The exploration of cosmic horror often serves as a reflection of humanity's broader fears: fear of the unknown, fear of losing control, and fear of our own insignificance. These themes resonate strongly in our modern context, where rapid technological advancements challenge our understanding of what it means to be human. The emergence of artificial intelligence, genetic engineering, and other transformative technologies evokes both awe and trepidation. As we venture into uncharted territories, we must grapple with the ethical implications of our creations and the potential consequences they may entail. As we continue to probe the depths of cosmic horror, we must recognize the profound role that fear plays in shaping our understanding of existence. Fear serves as both a motivator and a deterrent, propelling us to explore while simultaneously urging caution. The stories we tell, and the philosophies we ponder reflect our attempts to navigate this delicate balance. The legacy of cosmic horror invites us to confront our fears head-on, embracing the unknown while recognizing our own limitations. In essence, the exploration of cosmic horrors transcends mere fascination with the unknown. It embodies our fundamental quest for understanding. It challenges us to confront our existential fears, encouraging us to embrace the complexity of existence and the interconnectedness of all life in the universe. As we grapple with the mysteries that lie beyond our comprehension, we are reminded that our journey is not just one of exploration but also of connection, both with one another and with the cosmos itself. Through this lens, cosmic horror transforms from a mere genre into a powerful metaphor for the human experience. It encapsulates the duality of awe and dread that accompanies our search for knowledge, reminding us that while we may be small in the grand tapestry of the universe, our pursuit of understanding is a testament to our resilience and creativity. As we continue to explore the cosmos, we do so with the hope that we can navigate the unknown with courage and curiosity, forging connections that transcend the boundaries of time and space. As we reach the culmination of our exploration of cosmic horrors, we stand at the precipice of understanding. The vastness of the universe serves as a reminder of our place within it, both insignificant and significant, vulnerable and resilient. The stories we tell and the questions we ask echo through the cosmos, resonating with the potential for discovery and connection. In our quest for knowledge, we may uncover not only the terrors that lurk in the shadows but also the beauty and wonder that exist within the unknown. The exploration of cosmic horrors invites us to confront our deepest fears and uncertainties, urging us to embrace the unknown while seeking meaning in our existence. It challenges us to confront our vulnerabilities and recognize the interconnectedness of all life. Through our journey into the cosmos, we are reminded that, while we may encounter terrors beyond our comprehension, we also have the capacity for awe, wonder, and the pursuit of knowledge. As we continue to gaze into the night sky and ponder the mysteries of existence, we are reminded that our journey is one of exploration, connection, and ultimately, understanding. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.